Hey guys, so today we're going to look at the Unit 7, Day 5 worksheet. We're going to look at a few of these because they're pretty quick. So looking at number 1, it says write linear and nonlinear on the line and explain your choice below the question. Well, we can tell this is a curved line, so our function is nonlinear, because the function needs to be a straight line in order to be linear. Looking at number 8, we see that we could put this into y equals mx plus b form if we subtract 2x from both sides. Divided by -1, and we would get y equals 2x minus 5, and because of that, our function is linear, because it's in y equals mx plus b form. If the function was not in y equals mx plus b form, then it wouldn't be nonlinear. Jumping down to number 14. In order to see if this is linear or nonlinear, we would have to find the differences between our x's and between our y's. So the difference between 6 and 12 is plus 6, between 12 and 18 is plus 6, and between 18 and 24 is plus 6. The differences between our y's, between 1 and 3, is plus 2, between 3 and 6 is plus 3, and between 6 and 10 is plus 4. Now, because we have all plus 6's for our x differences, but a plus 2 and a plus 3 and a plus 4 for our y differences, this makes the function nonlinear, because we have non-constant slopes. Flipping over to the back, we're going to look at number 17. 17 tells us to express the relation as a mapping, a table, and a graph, and then name the domain and range and figure out if it's a function. So first we have to make our mapping diagram. So to do that, we have to list our inputs and our outputs, and we're going to list those in order. So looking at our inputs, which is our x values, we have 4, -1, 2, and 3. So we would list these in order going down. So -1, 2, 3, 4. Now to find our outputs, we have to look at our y values in the coordinates. So we have -2, 1, -3, and 0. Listing these in order, we have -3, -2, 0, and 1. Now we have to draw the mappings. So to do that, we just look back at our coordinates. So our first coordinate is 4, -2. So we can draw a line between 4 and -2. Our second coordinate is -1, 1. So we draw a line between -1 and 1. Our third coordinate is 2, 3. So we draw a line between 2 and -3. Sorry, 2, -3. Our fourth coordinate is 3, 0. So we draw a line between 3 and 0. Then we need to write our table of values. So for this, we should be writing our x's in order. So our inputs are going to go in order. So we have -1, 2, 3, 4. And then we would put our y values matched up to their values. So looking back at the coordinates, -1 is paired with the y value of 1. 2 is paired with the y value of -3. 3 is paired with the y value of 0. And 4 is paired with the y value of -2. So now we can state our domain and our range. So our domain is our list of x values. So we already know all those. We know our x values are -1, 2, 3, and 4. So we're going to list our domain in order. Then our range, we know, is -3, -2, 0, and 1, which we see from our mapping diagram. So now we're going to make a graph of these coordinates, so we can use our table to help us. So our first coordinate is -1, 1. So we can go -1, 1, put it out there. Then we have 2, -3. And then we have 3, 0. So 3 zeros right there. then 4 and negative 2 is here. So then we can draw a curve between these. So now we have to answer the question, is it a function? So to test this, we would have to look at the vertical line test. So wherever we draw a vertical line on this graph, the function, or the graph, is only hitting one point at every spot. So the answer is yes, this is a function.